students were given this question, y times e raised to the power y times dx is equal to y cubed positive 2x e raised to the power y times dy. Now, make sure that you are able to notice e raised to the power y. Most of the times we would only see e raised to the power x, but this time we are watching e raised to the power y. So that means the form that we are looking at is not dy over dx, but dx over dy positive px is equal to q. So this is the form that we are looking at. So we need to convert everything into this form. So for that, what we need to do is we have to make the division. So we are going to be dividing by dy. So when we divide by dy both sides, so we would get y times e raised to the power y times dx divided by dy is equal to y cubed positive 2x e raised to the power y times dy divided by dy. So we have got something like this. So clearly the dy that you see here can be cancelled. So this would give us y times e raised to the power y dx divided by dy is equal to y cubed positive 2 times x e raised to the power y. Okay, now I want to move this 2x e raised to the power y to the left. So that would mean I now have y times e raised to the power y times dx divided by dy negative 2 times x e raised to the power y is equal to y cubed. Now I don't want to have quantities with dx over dy because I'm looking at a form like this, dx over dy with no coefficients. In fact, the coefficient should just be 1. So for that, what I'm going to do is I'm going to be dividing by y times e raised to the power y. So that would give me, when I divide, so it's going to be divided by y times e raised to the power y. This is going to be divided by y times e raised to the power y. This is going to be divided by y times e raised to the power y. Now when you do that, clearly these two quantities are going to get cancelled. So giving me dx over dy, that's one quantity, negative 2 times. Now I've got e raised to the power y in the denominator and e raised to the power y in the numerator. So these quantities can be cancelled. So this is going to be 2 times x of 1 over y. This is equal to, now the y that you see here can be cancelled with a y cubed there. So that means I have a y squared and then e raised to the power y. I'm going to move this to the numerator. So that would give me e raised to the power negative y. Now just to polish these things up, so this would be dx divided by dy negative. Now what I'm going to do is I'm going to have a positive sign here and then x quantity there, and then I'm going to write it as negative 2 over y is equal to y squared of e raised to the power negative y. So this is the way I'm writing. Why? Because I just want to represent it in this form. Okay, so clearly now you can see that this is the form that we wanted it to be. So now we can go on solving the question. So students, as I mentioned to you, this is of the form dx over dy positive p times x is equal to q, where my q and p are as follows. So my p is clearly negative 2 over y and my q is y squared times e raised to the power negative y. Now the integrating factor for this is going to be e raised to the power integral p. It's not going to be dx there, it's going to be dy there. So this is equal to e raised to the power integral negative 2 over y times dy. So now what we have to do is to just consider integral negative 2 times dy divided by y, which I can rewrite it as negative 2 times integral dy over y. Now this is going to be log of y, okay, log of modulus y, Of course, there's a negative 2 there. Now what you can do is you can move this 2 to the head of y. Why? Because we know that a times log b is going to be log of b raised to the power a. We know this formula. Now because of this formula, this is going to be log of modulus of y raised to the power negative 2. Now I can always rewrite this as log of 1 divided by modulus of y squared. Now this can be again rewritten as, since it is 2 there, we are always going to be a positive quantity obtained because of this fact. So that's going to be 1 divided by y squared, right? So this is what we have got for our integral p dy. But we need the integrating factor. So integrating factor is equal to e raised to the power integral p dy, which is equal to e raised to the power. In the place of integral p dy, we will have to substitute this quantity. So that is going to be log of 1 over y squared. Now just for sake of clarity, I am rewriting it as e raised to the power log of 1 over y squared. Now clearly the e and the log will get cancelled or absorbed. So that would give us a quantity 1 over y squared. So this is the integrating factor. Now the general solution is as follows. So we have to start with x times e raised to the power integral p dy is equal to integral q times e raised to the power integral p dy times dy positive arbitrary constant c. Now if we were to make the substitution, we would have obtained something like this. In the place of e raised to the power integral p dy, we would have to substitute by 1 over y squared. So what I would do is I would just start off by making the substitution. Okay, since e raised to the power integral p dy is equal to 1 over y squared and q is equal to y squared e raised to the power negative y. If I were to take this as 2, therefore 2 can be rewritten as x times 1 over y squared is equal to integral y squared times e raised to the power negative y times, in the place of e raised to the power integral p dy, I am going to have 1 over y squared times dy positive arbitrary constant c. Clearly the y squared that we see here can be cancelled, giving me x over y squared is equal to integral e raised to the power negative y times dy positive arbitrary constant c. This is x over y squared is equal to, if you were to integrate this is going to be e raised to the power negative y. The coefficient of y is negative 1, so divide by negative 1 positive arbitrary constant c. Now I can further rewrite this as x over y squared is equal to negative 1 divided by e raised to the power positive y positive arbitrary constant c. Now I don't want y squared to be there in the denominator on the left side, so I cross multiply. When I do that, I get x is equal to y squared times negative 1 over e raised to the power y positive y squared times c. Now I can suitably write this with c or with e power y being in the numerator, right? Depending on what you want, what form you want, you can rewrite this. Now if you are not happy with this form, you can always rewrite this as x is equal to y squared with a negative sign e raised to the power negative y positive c times y squared. Okay, so this is the form that we have got, and as I mentioned to you, it's up to you. In whatever form that you are interested in obtaining, you can always obtain. If you are seeing this in the objective type questions, then whatever they ask you, suitably you direct the solution